Hello there, and then welcome to a brand new lesson. This is Hap Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at multiplying algebraic terms. In our previous lesson, we learned how to add and subtract algebraic terms, and we established the fact that that can only be done if they are like terms. Multiplication is quite different. Whether they are like or not like, you can still multiply. Without much ado, let's quickly look at how we can do this. Now, before we get straight into some examples, let's look at the 3 golden rules of multiplying algebraic expressions. First of all, we need to multiply the signs. When I talk of multiplying the signs, what do we mean? It simply means if you have algebraic expressions that have signs in front of them, before you would have to multiply everything, take note. If you multiply a positive number by a positive number, your result is always going to be what? A positive number. If you multiply a negative number by a negative number, your result is always going to be what? Positive. So simply put, if the signs are the same and then you are multiplying, your result is always a positive. On the other hand, if you have positive and you are multiplying it by a negative, then you get a negative. Also, if you have a negative and you are multiplying by a positive, your result is also negative. So once again, if the signs are different, as you see here, positive, negative, your answer is always a negative. Negative and positive, different signs, your answer is always a negative. So the signs being the same give you a positive, and the sign being different gives you a negative. After multiplying the signs, you now take note of the coefficients. Now, by now, I would want to believe that you know what a coefficient is. So after multiplying these coefficients, that is the numbers that are before the variables, that is when you now go to the variables themselves. And when it comes to the variables, then I do expect that you have a little knowledge on indices, because that is what we are going to apply. Nevertheless, you can still continue and you would understand. So let's look at some examples that will help us understand these 3 rules. Now, in this first example, we have 4 multiplying 3x. So 4 times 3x. Following the rules, the first one says we should multiply the sign. What sign do we have here? And what sign do we also have here? They are all positive numbers. So positive times positive is going to give us positive. Most of the times when it's positive, we don't even write it. But this being the first example, I'll just write the positive. And then we now multiply the coefficient. The coefficient here is what? This is actually a constant. Then we have the coefficient here being 3. So 4 times 3 gives us a 12. Then we have just an x. This has no variable here. So we can just say x times 1, giving us x. And that is all. This being the first example, we see how very easy it is. So 4 times 3x is just 12x. Now let's look at another example. This time around, we have a variable times a variable. Following the same procedure, it says x times x. So what do? We multiply the coefficients. There is 1 here and then there's 1 here. So 1 times 1 gives us 1. Then we have x times x. X times x here applies the rules of indices. So you just, since they are the same variable, write x. And then if there is no power here, we always know there is a power of 1. So this 1 and then this 1. Whenever we are multiplying, we add the indices or the index 1 plus 1. So that we now have x 1 plus 1 giving us what? 2. So x times x then gives us what? An x squared. Very simple. These are the basic ones you would ever get. That is a number multiplying an algebraic, that is a number multiplying an algebraic term, then a variable multiplying a variable. Let's now apply these two together. That is multiplying a term by a term. So in this next example, we want to multiply a term by another term where they have the same variables. And this time around, they have coefficients other than 1. How are we going to go about it? So we have 2x times 5x. They are all positives, so we are expecting a positive answer. Now 2 times 5 now, 2 times 5 gives us a 10. So we have 10, and then the x times x gives us an x squared. As simple as that. If you want it explained further or into detail, then I can say all we did was to multiply 2 by 5, and then we now do what? Multiply the x by the x. And 2 times 5 gives us our 10. Then x times x gives us our x squared. As simple as that. What if the variables are different? You have 2 terms or more than 2 terms, let's say, and you are multiplying, but then the variables are different. What do we do? For this example we have here, it says 3a times 4b. And as you have noticed, the coefficient, the variable we have here is a, and that here is a b. So 3a times 4b. Multiplying the coefficients, we have 3 times a, which gives us, we have 3 times 4, which gives us what? A 12. So 3 times 4. And then we multiply a by b. So a times b. 3 times 4 gives us a 12. Then a times b gives us a b. Take note, unlike addition and subtraction, where we said they have to only be like terms, multiplication, as I said in the intro, isn't that way. Even if they are not like terms, you can still multiply as you have seen us do here, multiplying a by b, giving us ab. There are certain basic things you need to take note of. 1, when it comes to addition, x plus x gives us 2x. But then when it comes to multiplication, x times x gives us an x squared and not 2x. This implies x multiplying itself. This simply implies adding 2 of x's together. The same way, if you were to write x plus x plus x, you would get what? 3x. And then x times x times x gives us x cubed. So take note of these differences. They all have different answers when evaluated by substitution. Secondly, if you have 2x plus 3y, in addition or subtraction, it still remains the same. Why? Because they are not like terms. But as we have seen, when you have 2x times a 3y, that isn't the case. Even though they are not like terms, we can still evaluate to get 6xy. As simple as that. Let's take one last question and then we'll be done for this session. Now on your screen is this last example we'll be solving under multiplication of algebraic expression. You realize that I'm just looking at the basic examples. The reason being that going further will then be a tutorial on indices. But if you want a complete tutorial on indices and more complex examples, you can check the playlist on that and you'll be good to go. So for this example, we have 3x squared, then y multiplied by 4xy cubed. Now we apply the same set of rules. X multiplies 4 to give us 12. Then applying the laws of indices here. So let me simply write everything together. So we have 3 multiplying 4, and then x squared multiplying x, and then y multiplying y cubed. This is not to say we are working it in terms of grouping of like terms. You can do it straightforward, but for explanation and then simplicity sake, that is why I'm doing it this way. So you have 3 multiplying your 4 to give you 12. Then x squared times x gives us our x cubed. That is, since the bases are the same, 2 plus 1 gives us a 3. Once again, if you need more explanation specifically on these under indices, then we have y. There is 1 here, so 1 plus 3 gives us what? A 4. And this here becomes our final answer for the simplification or the multiplication of 3x squared y by 4xy cubed. This will be it for multiplication of algebraic expression. Now, next lesson, we'll be looking at division of algebraic expressions. As usual, I'll leave you some exercises so you try on your own. So here you have just 5 questions for you to try your hands on. See you in our next lesson, and bye for now.